right, you spin me right round, baby, right round. 9.3 rotations. Let's go ahead and rotate some of these things. In order for a rotation to happen, we actually need three things. The first is a point of rotation. You need a direction of rotation. It's either going to be clockwise or counterclockwise. This would be clockwise if you think of a clock. We'll abbreviate it CW. And then counterclockwise would obviously go this way. And we abbreviate it CCW for counterclockwise. All right. So you guys have to think about like an analog clock where it's just a regular clock with lines. With like the minute hand and the second hand and the hour hand. And then the very center of the clock is the point of rotation. And then the last thing we need for rotations is the angle of rotation. It could be rotated 1 degree, 2 degrees, but we're going to focus on the main angles of rotation. So we're only going to do like the 90-degree rotation or the 180-degree rotation, or maybe even a 270-degree rotation. So we'll focus on the more popular angles to work with. All right. Here's an example. We have a little arrow. It's pointing to the right. And then I want you to rotate that arrow 90 degrees clockwise around this point, this pivot point that's right here. Okay, so I want you to go clockwise, so this way, 90 degrees. Where do you think that arrow is going to end up? Go ahead and point to the screen to see if your finger ends up where the arrow is supposed to end up. And which direction do you think that arrow is going to point? Right now it's pointing to the right. Where do you think the arrow is going to go now? If I go 90 degrees clockwise. There it is. So if I took a string, tied it to the arrow, and then move it 90 degrees clockwise, that's where the new arrow would be. Okay? So there it is, our first rotation. Okay, let's go ahead and do some actual points on graph paper so we have exact answers, because drawing them freehand, you might be off by a little bit, but when we work on the coordinate plane, we're going to get the exact answer. So let's start off with this blue point, negative 1, 6. Let's go ahead and rotate it 90 degrees clockwise about the origin. So what that means is you're going to use the origin as the point of rotation, tie a string to that, and then rotate it 90 degrees clockwise. So 90 degrees that way. Where do you think it's going to end up? Let's see. There it is. We took it, turned it 90 degrees clockwise, and you end up at 6, 1. Let's do another one. Rotated 100 degrees counterclockwise about the origin. So again, about the origin means you're going to use the center as the pivot point, tie a string to it, a straight string to it, and then go counterclockwise 180 degrees. Where do you think it will land? At 1, -6. It actually landed right there. And if you think 180 degrees makes a straight line, so there's our straight line. Okay, now there's one thing you should notice is it actually didn't matter when we're dealing with 180 degrees if you go clockwise or counterclockwise. 180 degrees counterclockwise is actually the same thing as 180 degrees clockwise. So when you do 180 degrees, it doesn't matter which direction, you'll end up in the same place. Okay, let's do another example. How about 270 degrees clockwise about the origin? So we have the origin, and then we're going to go clockwise 270 degrees. So here's 90 degrees, here's 180 degrees, and then another 90 degrees actually puts you here. And that's 270 degrees. -6, -1. And then another thing you should notice is when you go 270 degrees clockwise, it's the same thing as going 90 degrees counterclockwise. All right, so there's a couple of options when you're doing these problems. You can go all the way around or go backwards, but the shorter way. Okay, and we're actually gonna get some rules for all of these angles. For example, if you look, our original point is -1, 6, but all of our answers are like very similar variations of the original point, and we do have rules for each one. So let's go ahead and go over those rules right now. Rotating rules. When you're rotating 90 degrees clockwise about the origin, and this only works if it's around the origin, your X and your Y are your original points, but your new points, you actually flip the X and the Y, and then you change the sign for the X. If you're asked to go 180 degrees, remember it doesn't matter counterclockwise or clockwise with 180 degrees. The rule is if you start with an X and a Y, all you got to do is keep the X and the Y, but then change their signs. And then if you have 270 degrees, that was a 270 degrees clockwise about the origin, then the rule is if you have an X or a Y, you actually flip the X and the Y, and then you change the Y to a different sign. All right, so those are the rules. And you don't have to memorize these rules. If you can visualize the rotation in your head, then you're good. But if you can't visualize it, then we have these rules for you. And again, they only work when you're going around the origin at 90 degrees, 180 degrees, and 270 degrees. Okay, so let's go ahead and rotate this triangle. So to rotate the triangle, you just rotate one point at a time. It's clockwise and it's 90 degrees. So we're going to have to go this way 90 degrees around the origin. So tie a string to the triangle and then swing it. Where would all the points be? So you can do this visually, point by point. So M is -9, 8. How does it go over here? Or you can use the rules. Remember, the rule was to take the X and the Y, flip them around, and then change the X. So notice it's -9, 8, so I flipped it around to get 8, -9, and then I changed the X. So that's why it is at 8, 9. And then you can do the same thing for T and the V. The T, flip it around, change the X, and the V, flip it around, change the X. Okay? And remember, these little tick marks means prime. So M prime, T prime, and V prime. That's the new location. It's the image. And there's our new triangle. I know it looks smaller, but it's actually not. It's just I used a thinner red line. And so it looks smaller, but it actually is the same exact triangle, rotated. All right. Last thing for the day is kind of tricky. What happens when we don't rotate around the origin, but instead we rotate about a certain point? When that's the case, none of those rules will work, and you have to kind of visualize everything. Let's start off with point -7, 2. Here it is. And I want to rotate it clockwise 90 degrees, but instead of from 0, 0, no more, we're going to go around -5, 1. So this is the point of rotation. We have to tie a string here and then go 90 degrees. So that actually makes it a little bit more difficult. I'll erase this and then draw these things in. There it is. -5, 1 is this point right here. So now that's our new origin. And then I just drew in a new x-axis and a new y-axis. Hopefully that'll help. And then we're going to swing it around 90 degrees that way. Okay? So we kind of have to visualize it. Where do you think it's going to end up if I tie a string to here and then swing it around? It should end up at -4, 3. There it is. Okay, and that's 90 degrees from here to here. All right, so if you're having trouble visualizing those things, next week we will be actually using what's called patty paper. So basically a clear piece of paper that you would lay on top of the graph paper and then physically just turn it so you can see it. If we were in class together, I could give you patty paper and you can see it. We can visualize it pretty nicely, but we'll try to do it on camera next week. But for now, that's all we got. Go ahead and try the homework.